Hi, this is the Science Chef. This video is a continuation of our solution to the May-June 2020 Cambridge IGCSE Chemistry Paper 4. Today, we'll be answering the final question, question 5. If you'd like to watch our solutions to questions 1 to 4, you can check the links in the description. Also, if you are yet to join our membership club, you can do so by clicking on the join button to get access to exclusive videos, live chats, and live tutorials where you can ask questions on any challenging topics in chemistry. Question 5. Question 5 says, ethanol is manufactured by two different processes. A. For each process, name the organic reactant and state the type of reaction. What are the keywords here? Ethanol. And not just ethanol, but manufacturing of what? Ethanol. That's the processes by which ethanol is what? Manufactured. First of all, let's look at ethanol. Ethanol is the most important member of the homologous series called what? Alcohols. With the general molecular formula ROH or CN H2N plus 1OH. Right? Where N does what? Starts from what? 1. Where N starts from 1 is greater than or equal to what? 1. Now, ethanol means what? Since it is what? Et, the prefix here is et, or the root is what? Et, that's 2 carbon what? Atoms. It means that N for ethanol is what? 2. So the formula for ethanol will be what? C2 H2 into 2 plus 1, right? OH. That gives us what? C2 H5 OH. Fine. Now, ethanol is manufactured in two different ways as stated in the word question. And based on your syllabus, the two methods are what? Chemical method. The chemical method and the what? Biological what? Method. The chemical method and the biological method. Those are the two methods used for preparing what? Ethanol. Now the chemical method involves what? The chemical method involves what? The hydration. Hydration of ethene. Hydration of what? Ethene. Ethene is an unsaturated word, hydrocarbon. So the hydration of ethene, that's addition of water molecules to ethene, will give us what? Ethanol. That's the chemical what? Method. While the biological method involves what? Fermentation. Fermentation of what? Of glucose. Fermentation of glucose. Fine. So since we are asked to just write the name of the organic reactant and state the product, then it means that for each of these, the organic reactant here is what? Ethene. Ethene. And the type of reaction is what? Hydration. Hydration. Hydration in bracket of ethene. Right, the second one is what? Sugar. You can say sugar in bracket, you can say glucose, and it's called what? Fermentation. That's what? Fermentation. Now let's throw more light on this. Hydration of ethene is a reversible reaction that occurs in the presence of phosphoric what? Acid, and at a temperature of about what? 500 degrees what? Celsius, and a temperature of about 60 to 70 atm. Those are the conditions for the hydration of what? Ethene to form ethanol. So this is your ethene, this is your water or your steam, a reversible reaction to form what? Ethanol, right? So you can see when water is a form of what? Addition or a combination what? Reaction, because water or steam is added to ethene to form what? Ethanol. Then, so fermentation on the other hand is the what? Fermentation is the breaking down of what? Is the breaking down of glucose in the absence of what? In the absence of oxygen by microorganisms to form what? To form ethanol and carbon 4 oxide. And what's the equation of reaction? That's glucose C6H12O6 in the presence of enzymes or yeast, right? Most times can be yeast. They are always yeast, right? This is 2, right? To give us what? Ethanol and CO2. Is the equation balanced? 2 there and what? 2 here. So that is the equation for what? Fermentation, right? Fine. So that's fermentation. That's the other one is what? Hydration. This equation here, this is fermentation. This equation of reaction for fermentation. This is the definition of fermentation, whereas this is the equation of reaction for hydration of what? Ethene. Hydration of ethene is a chemical process, right? While fermentation of glucose is a biological what? Process. So these are the 2 major processes or methods used in preparing what? Ethanol industrially. The next question says, alcohols can be oxidized to form carboxylic acids. Alcohols can be oxidized to form carboxylic what? Acid. When we talk about oxidation here, we're talking about either addition of what? Oxygen or the loss of what? Electrons, right? But in organic chemistry, oxidation is more of what? Addition of what? Oxygen. So what they are saying is that ROH can undergo what? Oxidation, right? To give us what? RCOO what? H, where RCOH is what? The general formula representation of what? Carboxylic what? Acid. Now we are asked to name a suitable oxidizing agent for this reaction. Suitable oxidizing agents commonly used for oxidizing alcohols in organic chemistry are acidified potassium permanganate. Since we're asked to name, that's what? KMnO4, acidified KMnO4, or acidified potassium dichromate, right? That's K2Cr2O7. Fine. Now these 2 guys, depending on their concentration, right, in the reaction, can oxidize the alcohol straight to carboxylic acid, or they can first of all oxidize the alcohol to alkanals before further oxidizing the alkanals to what? Carboxylic what? Acids. When the alcohol is oxidized to alkanal first before going to carboxylic acid, we call it what? Partial oxidation. In that case, for that to occur, it means that the alkanol or alcohol will be what? In excess, while this oxidizing agent, this will be in what? In limited what? Supply, right? When that happens, the alkanal, this is the alkanal, the alkanal can undergo further oxidation to form what? Carboxylic what? Acids, right? By the same oxidizing what? Agent. Or if the oxidizing agent, like I stated earlier, if the oxidizing agents are in excess, if they are in excess, yes, the alcohol can completely oxidize to what? Carboxylic what? Acid, right? Call that what? Complete oxidation. So the answer to that question is what? Acidified potassium permanganate or acidified potassium dichromate what? 6. Let's add 6 here. All right. Now alcohols can be partially oxidized to what? Aldehydes. Now aldehydes are alkanals, which we've explained earlier, right? So aldehyde can be partially what? Oxidized. Good. So aldehydes are a homologous what? Series of organic compounds. So what is a homologous series? A homologous series is a family of organic compounds which follow a regular structural pattern. They follow a regular structural pattern, and in which successive members differ in structure. They differ in structure by the CH2 group, that is this, the CH2 group, or a mass of 14. Let me repeat myself. A homologous series is a family of organic compounds which follow a regular structural pattern, in which successive members differ in their structures by the CH2 group, or a mass of 14. Right? Now, the common features of a homologous series, they have a general formula, like the alkanols, CnH2n plus 1 OH, right? Where N is greater or equal to 1. The alkanals, CnH2n plus 1 CHO, where N is greater or equal to 0. Meaning for the first member, N will be 0, right? And CnH2n plus 1 COO H, where N is greater for 0 for carboxylic acid. So these are all examples of homologous series. And you have to apply this formula in getting the members of each homologous series. You find out that each member will differ by the CH2 group. Let's take an example with the alcohols. The first member, when N is 1, will be CH3OH, while the second member will be C2, that's ethanol. First member is methanol, this one is ethanol, the next one is propanol. So you can see the difference between this and this is CH2. While the difference between this and this is CH2. So that makes them a homologous series. So for the alkanal, when N is 0, the first member will be HCHO, right? While the second member will be CH3, that's ethanol, CHO. While the third member will be C2H5, that's propanol, CHO. And you can see the difference between this and this. The first two is CH3, while the second is CH2. Fine. So that shows that these are homologous series. Fine. That is a major feature of homologous series, right? Other features are also there, but we will not dwell much on it. Question says, partial oxidation is achieved by reacting an alcohol with the oxidizing agent in distillation apparatus. Now this setup is a setup for distillation. What are we asked to do? Okay, so this is a setup for distillation. This is your light big condenser. This is the source of heat. No, distillation is a process, it's a separation process that involves evaporation and condensation. So first of all, the solution, the mixture will be heated, right? And when any of the substances gets to its boiling point, it will evaporate, right? And then when it evaporates, the vapor will get into the light big condenser, and with the water circulating around the light big condenser, it will do the drop in temperature will make the vapor to condense. The vapor will now condense. Let's do this. So the vapor will rise, get here, and when it now gets here, the drop in temperature will cause it to condense. It condenses and then starts dropping out as a liquid. Fine. So we are told to name apparatus A. And what's the apparatus? Light big condenser. And what's the light big condenser? What's it used for? To convert vapor to liquid. The light big condenser is used to convert vapor to liquid. Fine. And distillation, most times fractional distillation is used to separate two miscible liquids with close boiling point. But this is not fractional distillation. This is simple distillation. A simple distillation can be used to separate miscible liquids with very wide boiling point, right? Or can be used to obtain a solvent from its solution. Those are some of the applications of a normal or ordinary distillation. So the next question says, on the diagram, use one arrow to show where water enters apparatus A. So here, if you come here, this is where water enters apparatus A. So this is the water inlet, right? Which means that this will be the water outlet. Fine. The question said one arrow, so we only need one arrow. And remember, the direction of the arrow is also important. If you end up doing this and writing as water inlet, even though you got the right position, right, that will be what? Wrong, because the direction contradicts your description. Are we together? Fine. So for it to be water inlet, the arrow must point towards the outlet or inlet of the condenser. For outlet, it will move away from the tube of the condenser. Now the table shows some information about aldehydes. So talking about what? Alkanals here. Aldehydes, that's alkanals. Right? Complete the table. Name. Can you see? As if we knew that this is what the examiner will do. We already calculated, or we already done this here, right? Fine. So if we come here, the molecular formula is CH2O, which is what? This first member here, right? CH2O. So what will be the name? There's only one carbon, right? Fine. So let's come here. That's HCHO, right? What's the functional group here? The functional group is C double bond OH, right? That's the aldehyde functional group. So if you have to name it, remember we name using the prefix plus what? Root plus what? Suffix, where the suffix is the word from the functional group, and which is what? Now, right? So here it will be what? Now, and the root is obtained from the number of what? Carbon atoms present, and when it is one carbon atom, it is what? Met. When it is what? 2, it is what? Earth. When it is 3, it is what? Prop. When it is 4, it is what? Both. If you want to learn how to name organic compounds, right, watch our videos on naming of what? Organic compounds. We have added the link to the description. So how many carbon atoms do we have here? That's 1. So that's what? Met plus this will give us what? Now, met now. But the name of the compound, the IUPAC name of the compound is what? Alkanals. So we are going to name them in that format to be what? Methanol. Now you can even see from the examples given to us here, ethanol, propanol, butanol, not just ethanol, propanol, butanol. So means that the first member will be what? Methanol, right? So remember, this is a homologous series. What we did above, right? What we did above, we worked out the first 3 members. Now they want us to produce the 4th member. And we have already stated that the difference between each successive member is what? CH what? 2. So if we add CH2 to the 3rd member, what will we get? That will be what? C4H8O. Good. And that's our what? Butanol. Great. Now we are now asked to deduce the general formula of the word aldehydes. We are asked to deduce the general formula of the word aldehydes. Yes, while I was explaining, I used CnH2n plus 1 CHO to describe or to explain the general formula of the word of the aldehydes. But based on the question given to you and the examples, you have to give your formula based on this what? Example. So from this, we can say that here n is what? 4, is it not? Here n is what? 3. Here n is what? 2. And here n is what? 1, is it not? So now when n is 1, that's when carbon is 1, hydrogen will be 2. So for every atom of carbon, there are 2 atoms of what? Hydrogen, is it not? So it means that first of all, and oxygen is what? Constant. So it means that the formula will be what? CnH2 what? NO. So that gives us the general formula of the what? Aldehydes. Good. The next question says the structural formula of ethanol is shown, right? The C double bond O. This is known as what? A carbonyl what? The C double bond oxygen is known as what? A carbonyl group, right? We're told that the carbonyl group in aldehydes is at the end of the word? Carbon chain. Exactly. That's very, very correct, right? This is a reactive part of the word molecule. This is a reactive part of the word molecule. The molecule is meant to react. That is where the reaction will do what? Occur. What is the name given to the reactive part of any organic molecule, right? Remember when I was explaining something up here, when I underlined this CHO, what did I say? I said that this is the word, the functional word group. That's what determines the chemical property of the what homologous what series. So the name given to the reactive part of any organic compound or molecule is what? Is the functional group, because that is what will make the compound or the molecule to behave the way it does chemically, right? Good. Now the next question says complete the dot and cross diagram to show the electron arrangement of a molecule of ethanol. Inner shells have been what? Drawn. Fine. So now you are asked to do what? Use cross and dot diagram. First off, they've given us only two. For oxygen, cross, and carbon, dot, right? So for hydrogen you have to choose something. Let's use what? A box, a square box, right? So we are going to follow this pattern. They've given us the structure already, they're showing us the bonds, so we now have to complete using what? Cross and what? Dot. Now remember that every single bond represents what? A pair of what? Electrons, one from each what? Atom. That's if it's an ordinary covalent bond, but if it's a dative bond, then the two electrons will be from only one what? Atom, and it will be represented with an arrow. But this is an ordinary covalent what? Bond, or these are ordinary covalent bonds. So let's start with this hydrogen, carbon. So hydrogen will bring one, a box, while carbon will do what? Will bring a dot, right? That's the bond. Same thing here, hydrogen and dot. Same thing here, hydrogen, box, and dot. Yeah, now these are two carbon atoms, right? So a dot and a dot, right? Here a box and a dot. The overlapping of the orbitals is where the covalent bonding takes place, right? That's why we are putting the electrons in those overlaps, right? Now here oxygen and what? Oxygen and carbon. Now let's go to that structure. Remember, all these ones are all single what? Bonds. That's why we are having only a pairs of electrons there. But now here this is a double what? Bond. So it means that we must use what? Two pairs of electrons. So it means that for each pair it will be a cross and a dot, a cross and a dot, right? So now let's see, what is the essence of bonding? The essence of bonding is to make the atoms to attain the octet what? Configuration, right? Or duplet what? Configuration, if it is what? Hydrogen or lithium or beryllium, right? Fine. Now let's see whether these elements will attain the noble gas what? Configurations. Fine. Hydrogen 1 2 does attain its noble gas configuration. 1 2 1 2 1 2. So hydrogen is what? Correct, complete, and complete. Fine. Let's look at each carbon atom, the outermost shell. 1 2 3 4 5 6 7 8. Fine. 1 2 3 4 5 6 7 8. Great. So carbon is what? Complete. Carbon is complete. Let's check for carbon. Carbon, check. This particular carbon is complete. Check it. Now let's check the other carbon. Outermost shells only. 1 2 3 4 5 6 and 7 8. So that is also what? Complete. So we do what? We check this carbon. Now oxygen complete. Let's see. Oxygen 1. Oxygen is 1 2, right? So it's not complete. Oxygen is meant to have what? 8, right? So for it to have only 4, right? Only 4 atoms, it needs 4 more what? Electrons. So we are going to complete those 4 electrons with 1 2 3 4, and these 2 pairs of electrons are known as what? Lone pairs. They're known as what? Lone pairs of what? Electron, or non-bonding, or we call them what? Non-bonding pairs. Non-bonding what? Pairs of electrons, because they are not involved in what? Bonding. Are we together? They're not used in what? Bonding. But the other pairs of electrons used in bonding, like these ones, are called what? Shared what? shared pairs. This is a shared pair, or we call it what? Bonding pair. Fine. So that is that. If you want to learn more about chemical combination, right, watch our videos on ionic bonding and covalent bonding. We have added the links in the description. So let's move. The next question says propanone. Propanone belongs to a homologous series called what? The ketones. Now, in organic chemistry, aldehydes and ketones always go hand in hand, right? Aldehydes and ketones, they're like Siamese what? Twins. They're like Siamese twins. While these ones are obtained from partial oxidation, of alcohols. These ones are obtained from what? Oxidation. Partial oxidation of primary alcohol. Sorry, this one will be obtained from oxidation of what? Secondary alcohols. So let me repeat. Aldehydes are obtained from the partial oxidation of primary alcohols, while ketones are obtained from the oxidation of what? Secondary alcohols, right? So the question says ketones have the same carbonyl group as aldehydes, but the carbonyl group is not at the end of the what? Carbon chain, right? Remember, we are told that aldehydes have their carbonyl group where? At the end, which means that is R C double bond OH. But ketones now have theirs what? Not at the end, which means that something like this, C double bond O and what? R prime. It is in between two alkyl what? Groups. Why is this one the end? Because it is between an alkyl group and what? Hydrogen, right? This hydrogen that makes it what? A terminal what? Functional what? Group. But because what you have here in the ketones, the hydrogen is replaced by what? By an alkyl what? Group. It then makes the carbonyl what? Group to move to the what? Middle of the what? Chain. Fine. So you are told that propanone has the same formula as propanal. Remember, propanal is C3H6O, right? Fine. Now what term is used to describe molecules with different structures but same molecular what? Formula? First of all, let's draw the structure of propanal first. Propanal is 1, 2, 3, right? Prop 3. Then propanal. Prop 3 carbon atoms, right? Now is what? Aldehyde, right? So after that, remember we said when drawing molecular structure, carbon will have 4 bonds, hydrogen will have 1 bond, oxygen will have what? 2 bonds, while nitrogen will have 3 bonds. Good. So this carbon already has 1 bond, so it needs 3 more bonds to make it complete, and those 3 bonds are completed with what? Hydrogen. Here this one has 2 bonds, needing what? 2 more what? Bonds. And this one already has 4 bonds. This oxygen here has 2 bonds, while this hydrogen has 1 bond. So that is what? Propanal. So propanone. So you are told that propanone is also what? C3H6 what? O. If we move this guy from here to this middle, what will happen? Let's see. This will be what? 1, 2, 3, double bond what? O, right? Double bond O. Remember, we are told that it has the same molecular formula as what? Propanal, but the alkanal, the carbonyl group is not at the end, but in the what? Middle, because it's a what? Ketone. From what we were told here, ketones have the same carbonyl group as what? Aldehydes, but the CO group is not at the end of the word carbon chain. For it not to be at the end of the chain means that it is what? In the middle, in between 2 alkyl word groups. So which means that the only way you have this first carbon, second carbon, third word carbon, the only option that this carbonyl group has not to be at the end of the chain is carbon number what? 2, right? Because carbon 1 and carbon 3. Carbon 3, carbon 1 are all what? Terminal what? Carbons. So once it is placed on carbon 1 or carbon 3, it will be what? A propanol or an aldehyde, right? So for it to be a ketone or a propanone, it must be placed on what? Carbon 2. Great. So if you then go ahead and complete the bonds for each carbon atom, this will be 1, 2, 3. So that makes it what? 4. This one to 1, 2, and what? 3, making it what? 4 bonds for what? Carbon. So the total number of oxygen hydrogen atoms are now what? 1, 2, 3, 4, 5, 6. Great. So this is also what? C3, that's CH3, CO, CH what? 3, that is C3H6O. Fine. So that's propanone. Now let's go back to our question. What term is used to describe molecules with different structures but with the same molecular formula? So what is the term? That's what? Structural what? We call them what? Structural isomers. Isomers are compounds that possess what? That possess the same molecular formula but different what? Structural what? Formula. Right? So they are structural what? Isomers. Now what is isomerism? So isomerism is the existence of two or more compounds with the same molecular formula but different structural formula. Fine. So the last question says, suggest the structure of propanone, show all the atoms and all the bonds, which is what we've already drawn here. So that is the structure of what? Propanone, showing all the structures and all the what? Bonds. So that brings us to the end of the solution to our Cambridge IGCSE Chemistry Paper 4 for the May-June 2020, right? So with this now we've been able to solve all the questions in that paper, especially variant 41. If you were able to learn anything from this tutorial, hit the like button and leave a comment. Also, this is your first time here, subscribe to our channel and turn on the notification bell to always stay updated with new uploads. A wise man once said, hard work beats talent when talent refuses to work hard. So continue developing yourself, don't give up on your dreams until I see you when I'll see you.